Hello and welcome to week 5. This week we're going to learn how to filter our data frames using Python. This week we'll be taking a look at Boolean logic, which will form the basis of all of our filtering. We'll learn how to filter data frames using Boolean logic. We'll use filtering to find dirty data and figure out where we can spot clean data. And finally, we'll take advantage of aggregating and grouping data frames to transform them further. Let's take a look at our first challenge for this week. We've been given a data file which contains COVID-19 outbreak settings in the province of Ontario. We've been asked to perform the following. Filter this CSV file to include only outbreaks in workplaces. Filter this CSV file with outbreaks which are in workplaces and education settings. Filter this file with outbreaks that are in the Huron-Perth, Lambton County, and Niagara Region public health units. Filter this CSV file where there's 10 or more active outbreaks. And finally, provide a CSV file where there are 20 or more active outbreaks in workplaces and education settings, or where there are more than 40 active outbreaks. In order to accomplish all of this, we are going to need to take advantage of filtering data frames in Python. And we're going to do that by covering something called Boolean logic. Before we get into that, let's take a look at the file so we know what we're dealing with. Our data file this week is table 1 ongoing outbreaks phu.csv, and this is a daily snapshot of COVID-19 outbreaks by setting and date in the province of Ontario. And this data has been adapted from the following data source. Let's take a quick look at it using Spider. All right, we've jumped over to Spider, and we're taking a look at table 1 ongoing outbreaks phu. This is a large file. As you can see, I'm scrolling and we're well past 200 lines so far. This is a very, very large file. This is much larger than anything that we've dealt with so far. And if we want to find possible data issues, it's going to be very hard to eyeball issues, aside from anything that's obvious or jumps out at you in the first few rows. If we scroll to the very bottom, you'll see that we have 43,000 records. This is certainly more than we can spot clean by doing anything manually. So we're going to need to learn how to filter this data down. So let's talk about filtering data. Remember last week we filtered data by limiting how many rows we read. So we used the nRows parameter, we used the skip rows parameter in pd.readcsv. Well, this week we're going to need to filter down our large data set, over 40,000 rows. We are going to filter this data using code. Some data sets that you use, for example, from Statistics Canada, you may be able to scope or filter that data at the source and only export the data that you want. Some data sources will provide you what are known as data dumps. These are large collections of data that we are expected to filter on our own. So to filter this, we're going to need to learn how to write filter conditions. And how we write filter conditions is by taking advantage of something called Boolean logic. Boolean logic was developed by George Boole as a branch of algebra sometime in the 1800s. And in a Boolean expression, you have either true or false. So Boolean logic is used almost everywhere in programming, and we're going to use it to filter our data sets. And in order to represent true and false in Python, we use uppercase T, R-U-E, and uppercase F, A-L-S-E, true and false with an uppercase T and an uppercase F to represent the values true and false. Let's try an example in Python. So let's say we have a student, Alice, and they're enrolled at the University of Waterloo as a student. We can represent these two statements by using two variables with the value true assigned to them. So we have the variable Alice is student equals true, and then Alice attends Waterloo is equal to true. Then we can write another statement that answers the question, is Alice a student at the University of Waterloo? We can write that with the following expression. Is Alice a UW student is equal to Alice is student and Alice attends Waterloo. Let's try that in Python. We'll jump over to Spider and we'll start in a new file here, and I'll create a variable Alice is student, and I'll set this equal to true. Then I will create another variable called Alice attends Waterloo equals true. Now I can write the third statement. Is Alice a student at the University of Waterloo? By saying, is Alice a UW student? Set that equal to Alice is student and Alice attends Waterloo. Notice how the and keyword here is highlighted in a different color. And notice how the word true is highlighted in a different color. These are reserved keywords in Python. So the uppercase TRUE and the word and are both reserved for these Boolean statements. And we can print out the value of is Alice a UW student to confirm to ourselves that we get a result that says true. So we'll look down here in the console for the output true, and we see the output true. Now, why is this the case? Well, we're saying, is Alice a student? And is this statement true? And is this statement true? This is Boolean logic. Now, we could have, is Alice a UW student? We could have this output false by changing one of these operands to false. So Alice is student is still true. But if we change Alice attends Waterloo to false, we can answer the question, is Alice a UW student, by anding these two statements together. And look at that, we get the output false. So this is Boolean logic. So we can test for true or false by using different comparison and logical operators. So the first operators we'll look at are comparison operators. And these compare two values and produce an answer that is either true or false. For example, we can ask, is 7 greater than 8? This will produce false. 7 is not greater than 8. Another example, we can determine if two items are equal. Is the word Waterloo equal to the word Waterloo, both with an uppercase W? In this case, it would return true. Just a moment ago, we used logical operators, which allowed us to compare two or more Boolean values. In our previous example, we used the statement and to say, is Alice a UW student, by comparing Alice is student and Alice attends Waterloo. Two Boolean operands, and we said true and false, so this came out to false. Or if we change this to true, we can say true and true. But we can also combine Boolean expressions. So for example, we could say, is 7 greater than 8, or is 8 less than 9? We can also say, is 9 equal to 9 and 10 equal to 11? So we can write different tests for true or false by using our comparison operators and by combining these comparisons using logical operators. So what do these comparison operators look like in Python? Let's say you wanted to test to see if two items were either equal or not equal to each other. To test for this, we use equal, equal, so two equal signs. And to test if two items are not equal to each other, we use an exclamation point and a equal sign. So the equal, equal allows us to do the comparison equal to. Exclamation mark equals does the comparison not equal to. So for example, say we have variables a and b. A is equal to 6, b is equal to 7. If we print out the statement a equal b, we're asking, is a equal to b? This will print out false. So let's use this to create our first filter expression in our data frame. So we're going to filter our data frame on the outbreak group column. So we're going to filter our data where the outbreak group is equal to 3 education. And what we're going to do is create a variable that will hold our filter condition, and then we will pass that filter condition into our data frame to filter our data frame. So here's the pattern we'll follow. So if we're filtering on education, I'll create a variable called filter education and set this equal to data, where the column outbreak group is equal to 3 education. Then to perform the filter, I'll create a new variable called education outbreaks and set that equal to the value of data, which is filtered by this filter condition. Let's try this in Python. So I'm over here in Python, and I've got my code ready to read in my CSV file. We'll do that now. We have 43,317 rows and 5 columns. Now, to write our filter condition, first off, let's just confirm that we've got the right outbreak group name. So we want to filter where the outbreak group is education. Let's get a unique list of outbreak groups. So we'll get group types and set this equal to our data, the outbreak group column.unique. And we'll get a unique list of our outbreak groups. And we see that we have 3 education as one of our outbreak groups. So first, let's write our filter condition. So we'll say filter education is equal to data, where the column outbreak group is equal to 3 education. Now, behind the scenes, what Python is going to do is we're actually going to generate a calculated column. We're making a calculated column here. For each row in this file, we're asking, does the outbreak group for this row equal 3 education? And if we look at the filter education list, we see first row is false, second row is false, third row is false. But we see down here row 6 at index 5 is equal to true. Let's open up the data frame and confirm that for ourselves. So if I open the data frame on the left-hand side here and see, okay, so the 5th row at index 5, our 6th row, let's see here. Yes, it is. The outbreak group is education. Row 7 is not education. So we've actually created a calculated column here. So we can use this to filter our data frame down. So check this out. I'm going to say education outbreaks equals data, and then pass into the square brackets my filter education. And if I run this code, you'll see I have a new data frame with 8,000 rows, same number of columns, and if we look at outbreak group, it's all education. And in fact, we can confirm this to ourselves, can't we? How can we do that? Well, we can print out the unique outbreak groups for our education outbreaks. So I just copied the code for group types here, modified it so that we're getting the outbreak group unique type for education outbreaks data frame, and then printing that out to our console. And we see that we have exactly one element, 3 education. So we've created a data frame where we have just outbreaks that are in the education sector. So our filter condition, which is held by the variable filter education, contains true or false value for every row in our data frame. If the value is true, when we filter our data frame, the row will be included. If the value is false, when we filter our data frame, the row will be excluded. Let's get to our first problem in the problem statement for this week. We wanted to filter our data frame to include only workplace outbreaks. Then we want to export our filtered data frame. Using what we just covered, pause the video here and try to filter the data frame where outbreak group is equal to the workplace outbreak group. If you gave it a try, perhaps you came up with the following solution. So we create a variable to hold our filter condition, in this case where the outbreak group is equal to for workplace. Then we filter our data frame using the filter condition, and then we use the to_CSV function to export the workplace outbreaks. Let's confirm this code works. So we'll create a new filter condition called filter work, and we'll set this equal to data where outbreak group is equal to for workplace. Then work outbreaks will be equal to data filtered by filter work. And finally, we'll export this to its own CSV file by saying work outbreaks.to_CSV, and the file name being, in this case, table 1A, work outbreaks.csv, and we will not output our index column because we don't need it. So if we try that, we see work outbreaks, we have 9,151 rows. Again, we can confirm to ourselves that we have the right filter condition by printing out the unique outbreak groups for the work outbreaks data frame. And we see that for workplace is printed out. Therefore, we have only workplace outbreaks. Further, we can go to our work outbreaks file here, and we see, there we go. They're all workplace related outbreaks. And now, since we have filtered our data frame to the outbreak group workplace, each row is going to have the same outbreak group. And remember from week 4 that we can drop columns by name? Well, we want to make sure that our file name captures the intent of our dropped columns. So in this case, because we're going to remove the outbreak group, we want to make it clear that this CSV file that we're exporting captures the kind of data that we have exported. For example, this file, if we omitted the fact that this is for workplace-related outbreaks, somebody could read this file and say, oh, this must be for outbreaks in general. So we want to capture what kind of data is contained in this CSV file when we do our export. So we can drop, optionally, our extra column outbreak group. It depends on your needs. We've exported a CSV file that contains only outbreaks that occurred in workplaces.